Middle of the linked list. Given the head of a singly linked list, return the middle node of the linked list. If there are two middle nodes, return the second middle node. Okay, so if we have the linked list here, which is head, in this format here as an array, we'd return the middle node here would be the 3. So the output, since starting from 3, it would just return everything connected to 3 as well. So that's why it returned the 3, 4, and the 5. But yeah, that's how it got to 3. How to actually do this? Well, I mean, in all technicality, obviously you just divide 5 by 2, and then you would use like you'd find like the like a ground, do like a ground operation. But like a good way to do it, like an elegant way to do this at least, is to just use a fast pointer and then a slow pointer. And basically just make the fast pointer move twice as fast as the slow pointer and iterate it until either the fast pointer or the fast pointer dot next reaches like a null node. And once it reaches a null node, then the slow pointer would have iterated half as quickly, so it'd be at the middle point. So if we coded this, it would look like, okay, so first slow is equal to like head, fast is equal to head. Okay, so then while fast dot next, slow is equal to slow dot head, and then fast head, oh sorry, fast equal to fast dot next and slow is equal to slow dot next. And basically as they're iterating forward, right? So okay, so slow would be equal to head and fast would be equal to head first. Yeah, so both of them, we'd set both of them to head because head is where the linked list starts, so we'd be basically setting them to 1 here, both slow and fast. And then while fast and fast dot next, basically we're gonna have the fast pointer, which is gonna iterate twice as fast. It's gonna keep going until either that or that dot next, so the next node's connected to, reaches like null node. Because at that point the node before the node that comes before it, which is the slow node, would have reached like a middle index too. Well, like think about just 2 to the right. Fast node's at the very end, slow node would be at the middle. So slow would go dot next, it'd go up 1 every time, and fast would go up 2 every time, right? So it's just going 2 times the speed. Okay. And then after it's gone through the entire loop, we just return slow. Yeah, and this is just going to be O of n, because fast is going to go from head, which is the very beginning, to the very end of the list. So that's an O of n runtime complexity. And then the extra space is going to be O of 1, because we did not create any structures related to the input here. We simply used what we had, which was the head.